Okay, so what I'm going to do here is show you, this is going to be a little bit more complicated than the previous one, but what we're going to do is we're going to take the podium volume and break it up into two different wall types. One of them is going to be pretty straightforward. The other one is going to be like a sophisticated kind of attractor point thing. And so what I am going to do is I'm going to actually grab the podium massing because I want to show you how to work with a massing. Grab that. Pull this over, and I'm going to use the deconstruct brep. I'm going to use this, and then same way that I was using the list item before for like a few different, what is this, item selector. So I've got all the different faces of this now, of this brep, and so I'm going to do surface. I'm going to grab this, which is my back surface, so that's cool. That's going to be a party wall. This here is a front, that's going to be a curtain wall. You know, I did this with the curve before, but I'm going to do this with some surfaces. So then that is the, oh no, that's the bottom. That's the one I want, which is the back side. Yeah. So I've got party, curtain, curtain, party. So let me group these together. The party wall is going to be straightforward, but I just wanted to show you you can use a wall from profile, add wall profile, instead of using a curve. So what it's going to actually get is the outer bounds of it. And so we just have these, I might need to graft these as they go in. Yeah, so I'm just going to graft them. So this is basically giving me, you know, the same, it's giving me a native basic wall here. But it's using a profile curve rather than a curve that indicates the some sort of location on the wall. So the only thing that I would do here is probably maybe look at the locate, like maybe we just flip this. Let me see, is this giving me, oh, it's, I think we have to flip it. We can allow the joins. And then we also need to get the location line to be let me just get these, and then the location line. This will set this to be tracking mode, replace, and then let's do this location line, see if we can get that in the right place. It might, because it's using a curve versus surface, it might need to do some flipping, but this, you know, this is getting it kind of where, this is getting it where we want it to be. So that's that. That's, you know, we just get that out of the way. Now let's do the fun part, which is these curves for this. I'm going to try to do sort of like a Broad Diller Scofidio type facade on this part. And I'm going to rely on Lunchbox to make this nice and easy to start. So what I can do is I can go into Lunchbox, which is L here. They actually have this skewed quads panel, which will make life super easy. So I can just plug this in and get these skewed quads, which is awesome. And I'm going to do the same thing on both facades, but what I want to be able to do is do it by dimension. And so I'm going to do a, under surface here, there's an analysis that gives me the dimensions of a surface, the U and the V's. So I'm going to take that, I'm going to do a division on the U, and I'm going to make a slider 0 to 5. Plug that in, and then let's do the same thing with V. Okay, so like this might be too much. Yeah, so we can kind of get this to feel how we want it to. And then this is working the way I want it to. So all I'm going to do is cut and paste this, and I'm going to swap the surfaces for this and then for that. And now I've got this operating on both facades. Super easy, super straightforward. Let me hide some of this stuff. And I'm going to make it so that I get this, I'm just going to actually merge these two lists. This gives me A and B. Panels A are the ones that are not trimmed at the top and the bottom. So these are essentially complete panels. So I'm going to do these and put these together. So now I've got those. I'm actually going to do like a little offset here, but we'll make it parametric to show you guys some attractor point workflow. This has to be negative. I'll show you how this is working. Okay, so now I have like an offset, but I want this to be parametric. So before I showed you I had this curve, that control curve. Let me redraw that. So the way that I'm going to do that is I'm just going to go to plan. I'm going to draw this curve. I'll put it on the control curve layer. So just kind of like on the ground all around my building. I'm going to move this up. I'm going to turn off snappy dragging for now and make it smooth dragging. So I can just sort of like give this some variation. Again, this is just like random. There's lots of different ways you could do this. You could use an image and map it to the surface, which is pretty cool. But let's just do that for now. We can manipulate it later. But that's just like a control curve that indicates where I want it to open and close. And this attractor point workflow is pretty straightforward. So what I'm going to do is just grab that curve, bring that in, and then I'm going to do an area here of this, and I'm going to actually get these centroids, and I'm going to do what's called a pull point. So I have my points to search from, my geometry, that's the points to search from, the geometry that pulls is the curve. And you'll see it creates a bunch of these points on here. So that's the point on the curve that's closest to these different panels. And so what I can do is I can then take the distance between those points and use that for my offset value. But if I try to plug it in here, it's way too big. It's going to become a mess, right? So I have to what's called remap these numbers. So what I'm going to do is I'm going to say take all these values. My source domain is actually the bounds of this. So it's the bounds of these. That's my source domain. And my target domain is kind of whatever I want it to be. So I'm going to do construct domain. Slider. And then here's my target domain. And so let's say we bump it up to 8 or change. So I'm going to take these remapped values and plug these into here. So what you'll see is we actually get a bunch of different offsets, and as closer as they are to the curve, the more they will open because the offset will be less. So the closer to the curve, the more open it is, and I can sort of like, make this really low to kind of get those closed ones to be even more closed, and I could open this even more to make that open even more. And you might need to play with these depending on the size of your panel. So like if I add divisions or remove divisions, this might fail. You know what, I actually want to get rid of this redundancy here, so I'm going to plug, oops, not that. Plug this into there, plug this into here. So like if I was to scale this back, you'll see that these start to fail. So what I would need to do is just come in here and bump this up so this offset's not so, actually, I got to pull this down so the offset's not so big. So there you go. So you will have to calibrate these depending on what you do here. So if I move this back up to 4, I can, I can push those. But yeah, so now what I have is all these offset curves, and I have my original curves. So I just need to loft these together. So what I'm going to do is graft this list. Graft this list. And now I've got, I'm going to simplify this list. I'm going to simplify this list because what that does is, let me show you what that does. This has like a whole bunch of branches that are empty, or it's got zeros, so it's like splitting it way too much, more complex than it needs to be. Simplifying it makes it so that it removes all those zeros and all of those layers of branching that are actually not really changing anything. And so I can then take those, and now I have, it's going to think for a second, but I have all of these little sort of curves, panels. Let me hide all this stuff so you can see it better. So like I have those sort of frames there. And then what I'm going to do is I'm just going to extrude these out. I'm going to extrude them. I can flatten this again now that my loft is working. And the question is, where do I extrude them? So what I'm going to do is evaluate this surface to get the normal of the surface. This is important because you don't want to just use X, Y, Z, depending on which direction your surface is facing. And if this was curving, we'd want them all to kind of extrude in the direction of the surface normal. So I'm just going to do a multi-directional slider, which will give us the ability to evaluate all over a surface. I'm going to reparameterize this. And now what I have is the center of all those, and I get the normal of that. So what I want to do is do the extrude. I'm going to use an amplitude component, which gives me the vector, and I can use a slider here to control how far it gets extruded. And so I get this, and it's going to think for a second, but we're going to get all these little solid panels. So yeah, so that's my twisted diamond pattern. And we can make those a little thicker if we want. And the last thing is we need to just do this same exact thing for the little leftover panels. I could offset those, but for the interest of time, I'm just going to keep those as solid. But what we'll end up having is we're going to take, I'm going to lock the solver for a second so I don't cause problems. I got to merge these. Merge. And then I'm going to plug these into my evaluate surface. And I'm going to plug these into my extrude because this is just, we don't have to loft or anything. We're just doing that. So let me unlock. So yeah, now I have these little diamond patterns. So what I can do is, last thing is I'll merge these one more time. So I have these and I have these. And what I'm going to use is I'm just going to use the same direct shape component that I was using before for the columns. So we have our add geometry direct shape. I'm going to plug in, let me do the category first. Right click on this. I'm going to set this as a curtain panel. And then the geometry here is going to be those. It's going to think for a second, and then we're going to get all of these diamond panels in Revit. So if I come in here, here's that system, and it looks pretty good in here. So, you know, trying to get this sort of adaptive gradient pattern would be very tricky in Revit. We could use an adaptive component probably and do this. The other thing would be to try to create like a bunch of different custom wall, curtain wall panels and deploy them, but that would also have to be scripted. So this is a good way to kind of just get a complex pattern in. Now what you'll notice is, because this is one big curtain panel, which we might not want, especially if we wanted to get like a schedule or count these panels. So what I'm going to do is come back in here. Last little thing, I'm just going to graft this, and you'll see it's going to think for a second, and then it's going to actually put each panel as its own little individual panel. So if I go back into here, now each one of these is its own panel rather than it being one big block. So that's the difference between flattening before a direct shape and grafting. All right, cool. So almost there. What we're going to do is show adaptive components, and that'll be the last sort of facade system, and then we can look at the whole building all together.